Number 30, they give me these angles and sides. Well, let me fill in the blanks. Here I'm going to say this is a 2 and this is 4. Remember, those triangles are not drawn to scale. I'm going to say, you know what, let's see B right here. This is angle C, and this is A, and this is little a. So I want to start with an angle on an opposite side. They're right there. I would say the sine of 40 degrees to 2 equal. Do you see the only thing I could find is angle C in this case? Because I do not know this angle or this side. So I must say that's the sine of C divided by 3. And if I cross multiply, sine of C would equal 3 times the sine of 40 degrees divided by 2, which happens to be a 0.96. 1. My reference angle would be the inverse sine. I plug this in my calculator, and that gives me 74.6 degrees. 2. Sine is positive in 2 quadrants. That's going to happen every time. Sine is positive in quadrant 1 and in quadrant 2. If this happened to be 74.6 degrees, I don't like that at all. Make it nicer. If this is 74.6 degrees, then C could be 74.6 degrees. That's one possibility. I'll touch on that and use that, see if that works. And if they told me that this is 74.6 degrees, then this angle will be 180 minus that. So it could also be 105.4 degrees. I will play with that possibility as well and see if that works. I take the first guess and I'll say, all right, let's start by saying this right here happened to be a 74.6 degrees. In that case, I know that angle A is 180 degrees minus 74.6 degrees minus 40 degrees. And in this case, A will turn out to be, let me just check my calculations, 65.4 degrees. So in this case, I am using C equaling 74.6 degrees. And what's left? Well, I know what A is. I could find A to be, I just found A, I'm sorry. I'm confused. This is 65.4 degrees. Alright, and now I could say the sine of 40 to 2 equal the sine of 65.4 degrees to A. I don't like how that's looking. I want it to look nicer. This is 65.4 degrees. And if I cross multiply and solve, A would equal 2 times the sine of 65.4 degrees divided by the sine of 40 degrees. And A would become a 2.81. And that's fine. Now, I'm going to go ahead and say, you know what? This is one possibility. I got C, I got A, and I got little a. I could go back and say, well, let's see. If this was 40, this was a 2, that was given, and this side happened to be a 3, then this side right here, this angle, could have been, and this is not drawn to scale, of course, could have been 105.4 degrees. Is that possible? Well, if this is angle A and this is side A, now I'm saying that C is 105.4 degrees. I am saying if I take angle A, that's 180 degrees minus 40 degrees minus 105.4 degrees, and I can get A in this case to be 39.6 degrees, 34.6 degrees. So here I'm getting this to be 34.6 degrees. And once I get that, I could say the sine of 40 to 2 equal the sine of 34.6 to A. And A would equal 2 times the sine of 34.6 degrees divided by the sine of 40 degrees. And if I plug this in my calculator, I do get that to be at 2.83. And that does work. So in this case, I have two triangles. I could have two others. What do these mean? You could ask me during the discussion. I'll be more than happy to show you. 34 is the last problem. This says B is 4. Let's say that's 4. And the angle opposite of 95 degrees. Very good. C, let's say this is C, this is 5, and this is A, and that's A. So I could do this two ways. I could do it the brute force, sine of 95 degrees to 4. Again, I need an angle on the side opposite of that. That should equal the sine of C to 5. And if I cross multiply, the sine of C will equal 5 times the sine of 95 degrees divided by 4, which happened to be 1.24, and this will have no solution. I could have figured that out also by saying, look, isn't 95 degrees bigger than 90? That's the biggest angle. This or that can be bigger than 90. Isn't this side smaller than this? That's impossible. This angle must be bigger than this angle if this side is bigger. Since the smaller angle has the smaller side has the biggest angle, there's no way that could happen. So here you say, either you give me the empty set solution or you say no solution. You don't need both, one of them. On number 38, it says, use the illustration number 37. Okay, there's the illustration number 37. You're taking a ski lift to find the height QD. If I look for QD, this is really what I want. Oh, come on, there we go. I want this height. Well, let me see how I could do this. Anytime you're given a word problem, if you could mimic the problem and eliminate the 3 dimensions, whatever the words are, just go for the triangle. Pretty much you'll get it. Pretty much. If I take that top piece, so this is what I'm thinking. I know this is 25 degrees. If I could figure out, this is the height, this is what I'm looking for. This is a right triangle. If I could figure out either this side or this side, I'm in good shape. Well, I know this side is 1,000. I know this angle is 15 degrees. And if this is 25 degrees, if this is 25 degrees, don't I know what this is? Because this is a straight line, it's 180 degrees. So wouldn't that automatically become 155 degrees? If I know two angles of a triangle, can't I figure out the third? 155 plus 15, 170, this is 10 degrees. Now, do you see that using the law of sine, I could figure out what this side is? And remember, this side is the hypotenuse for this triangle. And if I know what the hypotenuse is, pretty much I'm done. So I could start by saying the sine of 10 degrees to 1,000, that's this part, equals the sine of 15 degrees to this side, I'm going to call it L. Well, L will equal 1,000, the sine of 15 degrees divided by the sine of 10 degrees. L turns out to be, L is really QP. I should have just stick with that. It doesn't matter. This turns out to be 1490.5 feet. If I know the hypotenuse is 1490.5, now can't I say, and I'm talking about now the right triangle, can't I say the sine of 25 degrees is this height, which is QD, divided by the hypotenuse? And if I cross multiply, that is 1490.5, the sine of 25 degrees, and this height will be what in feet? 629.10 feet. And there it is. The next problem talks about a bridge. The highest bridge in the world is this bridge. They name where it is. Sightings are taken from the same point at the water level under the bridge. This is the first piece of information that I need, and it's right there. So they take two sightings, and they indicate on the figure. Now keep in mind, if this angle was equal to this angle, then that would be half and half. But since those angles are not the same, well, it's slightly different. Now, what is it that they want to know? They want to know how high is the bridge. They're trying to figure out what this height is. Well, I know an angle. This is the opposite, adjacent or hypotenuse. I know an angle. This is the opposite or the hypotenuse. If I could figure out one of these sides, I'm in very good shape. Again, get out of this 3D business and draw your triangles and see what's given. And go from there. That's normally how it works. So if I glance at not the right triangle, the entire triangle, this is 880. This is 69.2 degrees, and this is 65.5 degrees. One, I could figure out what this angle is. I could say this angle is 180 minus this angle minus that angle. So if I subtract those, I could figure out that if I take 180 minus 69.2 degrees minus 65.5 degrees, I'll get this to be 45.3 degrees. This is 45.3 degrees. Now, can't I use the sine of 45.3 degrees to 880 to figure out either side? Let's say that side. Can't I say that's the sine of 65.5 degrees divided by, call it x? Wouldn't that mean x equal 880 times the sine of 65.5 degrees divided by the sine of 45.3 degrees? And that turns out to be 1126.57. So if I know this is 1126.57, let me double check. Yep. Now, if I look at this triangle, this right triangle, wouldn't you say this is 65.5? Oh boy, forgive me. Let me try that again. There. If I know this is 90, can I get this? Yeah, this is 69.2 degrees. This is h, and this is 1126.57. Wouldn't you say the sine of 69.2 degrees equal the opposite over the hypotenuse? And if I plug this in my calculator, h would equal 1126.57 times the sine of 69.2 degrees. And if I plug this in my calculator, I will get 1053.2 feet. I just want to set up one more problem in the time lab. Number 46 talks about a flight attempting to fly from point P to Q, right? An error is made by 10 degrees. This is 10 degrees. And it's given the figure. After flying 50 miles, the plane turns and flies 300 miles. If the constant speed of 250 miles, how much time was lost due to the error? Okay, let me rewrite this just so I'm going to get you started on how to do this. This is 10 degrees. This is 50. This is 300. Well, guess what? I could figure out this angle, I could say the sine of 10 to 300 equal the sine of this angle to 50. Once I know that, I could figure out this angle, and I could figure out what this actual distance is. And once I do that, I could figure out this distance, use distance equal rate times time, and figure out how much time did they lose. The number is going to be very small, and I'll answer any questions in the discussion. There's the homework.